Okay, I will get started now. So hello everyone and welcome to day 2 of the workshop on Itokawa in the dawn of asteroidal sample return. I'm Cyrena Goodrich of the Lunar and Planetary Institute, and I'd especially like to thank those of you who are joining us from distant time zones. So good morning, good evening, and good afternoon to all. Today's session is about asteroid-meteorite connections and lessons from Itokawa. Next slide, please. So establishing connections between asteroid taxonomy and meteorite taxonomy is a fundamental problem in planetary sciences. And it's complicated by the fact that both of these taxonomies are very complicated with multiple subdivisions, complexes, groups, subgroups. In the meteorites, we have classes, groups, subgroups, types, subtypes, and so on. And it's really hindered by the fact that asteroids and meteorites are classified by very different methods and at very different scales. Asteroids are classified principally by visible near-infrared spectral shape and features, and these are measured from afar. Whereas meteorites are classified by mineralogy, petrology, chemistry, and isotopic compositions, which are measured up very close in the lab. Next slide, please. So what methods do we have for making connections between asteroids and meteorites? Well, the classic method is laboratory measurements of reflectance spectra of the meteorites and comparison to the asteroid spectra. And there are advances in this type of analysis going on all the time, and I think some of them will be discussed in today's talks. Then we have missions to asteroids, starting with non-sample return missions. The first such mission was the NEAR mission to asteroid 433 Eros. In the case of non-sample return, we still get observations of the asteroids from much closer than they're made from the Earth, and different types of observations, and these can help to support connections to between meteorite and asteroid types. The NEAR mission to Eros supported the connection between ordinary chondrites and S-type asteroids, but it did not prove it. And then we had the Dawn mission to asteroid 4 Vesta, which supported a connection between HED meteorites and V-type asteroids, but again, did not prove it. Finally, now we have 3 phenomenally successful missions to asteroids that brought back samples. And in this way, we were able to definitively establish connections between some asteroid types and some meteorite types. A fourth method that we have is meteor tracking and rapid meteorite recovery. And this is especially useful if a reflectance spectrum of the meteor or the asteroid is measured pre-impact. There has been so far only one case in which that actually happened. That is the asteroid 2008 TC3 and the meteorite that was recovered from it, Alma Sitta. But many improvements and advancements are being made in this field all the time, and we're going to be hearing about some of them today. So that's all I have as an introduction, and I'll just turn it over now to the co-chairs for today, Mike Zelensky and Tasha Dunn.